Hello everyone. In this video we're going to be solving a rational equation. So we have the following equation: 2x divided by 2x squared minus 5x plus 3 and 13x divided by 2x squared plus x plus 3, and their sum is equal to 6, and we're going to be solving for x values. I'll be presenting two methods, and the first method will be a little painful, so bear with me on that, okay? So first method, I'm going to make a common denominator. Let's go ahead and crisscross applesauce, multiply the 2x by this, which is 2x squared plus x plus 3, and multiply the 13x by that, which is 2x squared minus 5x plus 3, and then all of that is divided by the product of the denominators, right? Obviously, another method to find a common denominator could be factoring each of these denominators and see if they have a common factor. But even though this expression is factorable, this one probably isn't. I haven't checked it, but it looks like it's not factorable. Anyways, that's just another approach when applicable. Now, this is going to give us a quartic equation. Let's go ahead and distribute. If you go ahead and multiply 2x times 2x squared, you're going to get basically 4x squared for 4x to the fourth from here, and you're going to get 26x to the fourth, which is going to give you 30x to the fourth. Here you're going to get 4x to the fourth. When you multiply that by 6, you're going to get 24x to the fourth. Subtract them, put it all together, and again, this is going to be super duper painful. That's why we're not going to proceed with that, and I don't think anybody in their right mind would do it. But again, if you want to you have plenty of time and you want to try it out, you can. So we're thinking this is a competition problem. I think it's from Russia. I can't remember exactly which competition, but I remember seeing it in one of the books that I have in Russian. Anyways, and there is something tricky about this problem, which if you discover that, it'll be very easy. So let me rewrite it, and then I'm going to tell you what the trick is and how you can identify it, because these problems appear on competitions, and obviously they are specially designed, or some people call it contrived. Okay, so we have this interesting sum, right? But look at the denominators. Certain things should get your attention. For example, both of these quadratics have 3 as their constant term. But not only that, there's a 2x squared here and there's a 2x squared here. In other words, the two terms are the same for these denominators. And in the numerator, we have some multiple of x, and both of these are of the same type. So if, for example, if one of them was a constant or contained x squared, then it will be a different story, and it probably wouldn't be a good story. And then on the right-hand side, to make matters better, right, not worse, we have a constant. Cool. Here's what we're going to do. Since 2x squared plus 3 appears in both denominators, and I'm not going to substitute that for anything. Before that, actually, I need to do something. I'm going to use substitution, but first step is not that. I'm going to go ahead and divide the numerator and the denominator by x. In other words, you can look at it this way. If you don't want to divide, I'm going to factor out an x here, and then factor out an x here, which I can do, right? And then now notice that, and nothing changes obviously on the right hand side, notice that 2x plus 3 over x appears in both denominators. Of course, that shouldn't be a surprise. But not only that, I can go ahead and cancel out the x's. But one thing you have to make sure, x does not equal 0. And obviously, if you look at the original problem, if x is 0, you're going to get 0 plus 0, which is not 6, right? So x equals 0 is not a solution, so we're allowed to do that. Divide both by x, okay? Cool. Now, we got a simpler equation, because if you consider this sum now, 2x plus 3 over x, and you can call that something, right? How about y? You're going to get a much simpler equation. Let's go ahead and find out. 2 over y minus 5 plus 13 over y plus 1 equals 6. Notice that this is also rational, but it'll turn into a quadratic equation. That's what I mean by contrived or specially designed problems. Okay, now, the rest should be fairly easy. Let's go ahead and multiply by y plus 1 and y minus 5. Just make a common denominator, but this time it's going to be a lot easier. If you consider the first method, think about it. right? And at the bottom, we're going to have 6 times y minus 5 times y plus 1. I mean on the right-hand side. After multiplying both sides by the common denominator, let's go ahead and simplify. The left-hand side is obviously linear, so let's go ahead and start with this. I'm going to be getting y squared, but that's going to be multiplied by 6. And then from here, we're going to get negative 5y and 1y. So that's going to give us a negative 4y. In other words, negative 24y after being multiplied by 6. Negative 5 is the constant term, but that's going to be negative 30. Great. On the right-hand side, we have 2y plus 13y, which is 15y. And then 2 minus 65, you got to think about it carefully, is minus 63. Okay? So far, so good. Let's see. Hopefully, we didn't make any mistakes, and we can solve this problem easily. All right. Let's see. 6y squared, and then subtract 15y. It's going to be negative 39y. Minus 30 plus 63 is going to give you a positive 33. It's nice that everything is divisible by 3. Let's go ahead and divide by 3. And it's not going to change the solutions. 2y squared minus 13y plus 11 equals 0. This is really nice. You know why? Because it's y is the variable, right? Because both equations, you should be able to see that. But with the second one, I think it's a little easier to see that 2 minus 13 plus 11 is 0. In other words, the sum of the coefficients is 0. You know what that means? I talked about it in many videos. I always talk about it whenever it comes up. This means that y equals 1 is a solution. Nice. And by factor theorem, you should know this, y minus 1 is a factor if y equals 1 is a solution. So that gives us one of the factors. So you have a couple options. You can go ahead and take this quadratic, divide by y minus 1. By the way, this was a quadratic, so I could solve using the quadratic formula. That would be super easy, right? Anyways, you get the idea. Or you can manipulate this equation in a special way, which is something that I usually do. I will just break down the negative 13y as negative 2y minus 11y. And then plus 11 is going to give me something factorable. And this is going to be 2y times y minus 1 minus 11 times y minus 1. And of course, that shouldn't be a surprise because we know that this expression contains y minus 1. You know that, right? And if you go ahead and take that and divide by y minus 1, you're going to get this factor. But the thing is, from here, you're going to get y equals 11 halves. But y equals 1 is also a solution. Of course, in this case, we assumed it's not because we've already taken care of that, right? So we know that y equals 1 is a solution. But now we got the second solution. So together, there are two solutions. But we were not looking for y. So we got to go ahead and solve for x. What's the relationship though? This is the relationship. 2x plus 3 over x. 2x plus 3 over x is supposed to be y. Let's start with the easier case. Multiply everything by x. And then from here, I think we get another sum of squares. Or sum of coefficients 0? No. This time it's a little different, but you get the idea. You can solve it using the quadratic formula, right? Did I do it correctly? I think so. So x is going to be from here negative b plus minus the square root of b squared minus 4. Okay, it's going to have complex solutions or imaginary, whatever. b squared minus 4ac. What is 4ac? 24. Okay, that's going to be negative 23. So it's going to look like this. 1 plus minus square root of 23i divided by 4. And if we set it equal to 11 over 2, by the way, I'm assuming they're going to have real solutions from there. We should get some real solutions, right? I mean, that would be nice. If you multiply everything by 2x, not x, but 2x, that'll be better because that'll get rid of the 2 as well. And obviously, we're going to get a 6 here, and we're going to get an 11x here, right? Because remember, we're multiplying by 2x, not just 2. Okay, great. So this is going to become 4x squared minus 11x plus 6 equals 0. And then from here, x equals negative b plus minus the square root of b squared, which is 121, minus 4ac, that's going to be 96. And their difference, I think, is going to be 25. Yay, we got a rational solution. That's just going to be 5. And if you split it up, 11 plus 5 over 8 and 11 minus 5 over 8, x is going to be from here 2 or 6 over 8, which is 3/4. So we got two real solutions, two non-real solutions. And that brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.